Greetings, I'm Michael DeSanto and the host of this edition of Champion Chats, where we dive into proven success stories from around the fluid analysis industry. Today, we're joined by Scott Howard from Hy-Pro Filtration. Welcome, Scott.
Hi, thanks for inviting me. I'm glad to be a part of this.
We're glad to have you here today. Thank you for joining us on Champion Chats. We've had a chance to work together and talk a lot during some of our past customer summits and some other opportunities where we've connected and worked together. During that, one of the things that we really talked a lot about was contamination. And when we talked about contamination, we talked about particle sizes. What is the most important particle size to focus on?
The most important particle size to focus on is the clearance size particle for the most limiting component in your system. Whether that be the valve or the pump or other component in your system, the moving parts internally have a clearance. And it's the particle that fits in that clearance that gets work hardened and can cause more particles through damage internally in those components. So that's the particle that's the most important to focus on. Traditionally, that's going to be one of the smaller particles. So if you look at your ISO code chart, ISO 4406:1999, there's a 4, 6, and 14 micron numbers. The 4 micron includes 4 microns and larger. I like to focus on that one first when I look at the lab report, just to get an idea of where our clearance size particles are as far as concentration. And keep one thing in mind with the ISO code, it's a limit, not a target. It's something to avoid, not something to achieve. So we want to be under the limit at all times. So your clearance size particles and the components in your system will dictate that limit for you.
And think about that a little bit further. You talked a lot about different sizes, but how would one know what the size of the particle is?
We have to measure it. So there's really 3 particular methods that are common. One of them is on-site, online, with a laser counter. You can connect directly to your system. Another option is if you're at the location, you can collect a bottle sample and draw it through a patch test kit and look at it through a microscope. Or more commonly is collect a bottle sample and send it to a lab like POLARIS in order for them to analyze it with their laser counter and then add it to the lab report. So you have to measure it to know where your particle sizes are as far as concentration.
And when one gets their lab report and sees an increase in contamination, what steps should they take to address it?
It's a good question. The very first thing that I recommend when you see an increase on your lab report that doesn't look normal is to resample. And this is the very first thing that I would recommend, just to make sure that there was not an error done. Most times, I'd say over 90% of the time, whenever there's an anomaly on the lab report, it's due to the sampling procedure. Okay, so I like to resample first. Then, if it comes back with an increase and it's consistent that it is higher, we need to take a moment and look at some of the things that have happened with the system recently. Have we added oil recently? If so, was it pre-filtered or did we add oil that had more dirt than was already in the system and we increased the overall contamination levels? Did we have an event where we might have had a water leak? Water that leaks into the system brings dirt in. Water is not traditionally clean. So that's some of the first steps that I would take to try and identify what's going on. First step, resample. And then from there, if it is consistently higher, start to investigate some of the things that have occurred in the system recently to see if you can identify where the contamination is coming from.
In talking with you in the past, one of the things that you often talked about was an offline filtration loop. How does an offline filtration loop fit within a program?
I think an offline filtration loop is one of the most critical and one of the best cost-saving pieces of equipment you can use, because then you can size the filter correctly to maximize your dirt holding capacity. You can shut the offline filter loop down while the system is still operating and change the filter element. And if designed properly, your offline filter loop will do the majority of the filtering, which would allow your inline filters, whether it's on the pressure side, outlet of a pump or before a valve, or even on the return side, to just focus on the internally generated contamination in those lines. So an offline filter loop can really significantly cut down on the amount of money you spend on contamination control equipment on an annual basis.
Scott, maybe for our last question for today, can you share one recommendation on how maintenance professionals can better manage a successful fluid analysis program by mitigating contamination?
One of the recommendations I like to mention is to oversize the filter element. If you're adding an offline filter loop, oversize your filter element. If you have an opportunity to increase the size of the pressure filters, do that as well. And the reason is dirt capacity. If you double the size of your filter element without changing flow rate or viscosity or anything else, you're 4 times the capacity for simply doubling the filter element size. I'll give you an analogy. The internals of the filter element, the thickness of the media is where your capacity is. So the slower the velocity, if you use Tetris as a game, as an example, the slower the velocity gives the particles more time to organize in the thickness instead of face loading. So you can reduce your cost of operating the system by buying less filter elements on an annual basis by simply oversizing your filter elements. You have to change less. And so I do recommend that is something that it's a consideration for reducing your total cost of ownership while at the same time maintaining your ISO codes below the limit for the system.
And Scott, those are some really great insights for our maintenance professionals and others. We really appreciate you taking the time to share that information with us today.
Thank you for inviting me. I'm happy to be a part of this.
And for all of you, thank you for joining us on Champion Chats today. To learn more about how we help companies save more equipment and increase uptime, visit us at polarislabs.com. See you soon.